So this one of the example that I already tried just now. So I show you first the behavior or the step to use this for copy. So after you complete, and then you can see at the design tree here got one or copy one. So we can test first, is it okay? Can be adapt to the different environment or not? Is it robust enough to use or to save in the catalog? So in case it's not 100% perfect, okay, no problem, because we still can modify. So for example, I want to show you how to use. So I can right click and then I can instantiate. So here we can see what are the input. We can define a plane, trim, and point. So plane, we control the orientation, point the location, and then trim is the limit surface. So this one also is not 100% perfect yet. It still can define later just to check what workflow is it okay or not. So I need to create a new plane. So this is a new position, so you can create a new plane, then select this plane, then trim the support surface or limiting surface, point to set the position, preview. So this one look okay, then you can click OK. Okay, I can try one more, create one more point here, one more new plane. So basically all the input you need to add manually. And maybe you can try to adjust a bit. Okay. So I can try to instantiate one more time. Plane, trim, and point. This location also okay. So this one is quite robust, so we can save in the catalog, but later. Okay, first I want to show you the step by step how to create this for copy. So I open back my first file. So you can refer back to this file that I share, or copy.catpart. So first thing, because this one is our first template, so we need to make sure everything is datum is not referred to any reference. For example, trim. So this trim basically is referred to surface 1 and surface 2. So to avoid any conflict, this one we can isolate first. So you can isolate your trim surface, so it's not belongs to any parent and child. So we need to break this link, so you can isolate. So I can search, so I can isolate this surface. So surface 3 no longer belong to any parent or child. So these two also we can delete. No need to keep the reference. So this is our first reference surface, limiting surface, and then next you need to create a point. So for this situation or this example, I need to create point somewhere here. So location, no problem, any location should be no issue. Just to create our template first. And then one more, we need to add plane. So plane, I refer to the curve and then set position using point. And then this one also, point and plane is our main reference. So we need to break the relationship. For example, point refer to surface number 3 and then plane refer to point number 1. So because this one is our input, we need to break the parent and child relationship. So just simply isolate this point Then you also can isolate this plane. So all already independent, don't have any relationship between others element. So that's the first step. So just to highlight, to make sure everything is robust, that's why we use all element inside the generative shape design, point, line, plane, everything lah. So it's not possible to do inside the sketch. So sketch we have all the direction, so this direction cannot be isolated. Then later when you try to apply the power copy, it's not robust enough, so you have a conflict. So everything we need to use inside the generative shape design element, your frame and surface and everything. So after complete our reference, we can create our rig profile. So there are many ways to do. So the example I showed one of the method. So in case you've got any idea, you can try. But this first try. So I can intersect. For example, I need to intersect between these two to get the my profile. So I intersect first and then click OK. And then to create a line, diagonal line here, so I need to add 2 more points. So this point, you need to make sure how you want to control. So for example, the first point I want to define the height based on our reference point, point number 1. So I can change here reference using point number 1. So set a suitable length, for example 20. So increase a bit more, 50, and should be okay. Then the second one, I can add here, and also in this one I need to refer to point number 1 as a origin. So the distance is based on this point number 1. So the point number 2 calculate based on this reference point. Same also point number 3. So we need to think the workflow or how we can how this rig can be adjusted easily lah, where to control. So using our reference point. So point already okay, and then next we can draw line. So I can connect between these 2 points as my rig profile. So we can extend a bit more this line, make sure it's 100% or have more surface to yeah, this one only because I use cross profile. So this one we just draw exact size base point to point, because later I will use extrapolate. So this is my line, and then I need to fill up this area. So 1, 2, 3. I can trim first this wireframe to has a close profile. So no need to keep all the extra intersect line. You just need to have close boundary here as our rig profile. So we get something like this. Okay, next step, I can fill this profile using fill surface. Okay, so basically this is a surface of the rig. So you can hide the wireframe or the close boundary. So to be safe, we need to extend a bit more the edge here, because sometimes when we see the the position at different location is a curve V, so sometimes we need to have more surface to 100% the set. So I can extend this to edge using extrapolate before I thicken this surface. So extend 10 mm curvature, for example. So we need to make sure we have more surface, it's better. So then I extend here. So make sure everything is 100% intersect. Okay. So this is the next step to do, extrapolate to make sure everything is 100% touch to the limit surface. So to thicken this rib, I can use, for example, this volume. So no need to use a thickness at the pad. I can use thick surface volume. Select this surface. And then you define your rib thickness, how much. So both sides I set 2 mm. So basically volume is close surface, close profile. Okay. So this is our tip. This is our rib. So next step, you need to make sure this rib is cut using this surface number 3 or our limiting surface. So because this one we use under volume under the GSD command, so this icon we locate under the geometrical set. Actually the behavior is same like other element under the GSD. It's not thicken under part body lah. It's a different thing. So this surface is a volume. So the behavior is same like all this 3D element. So I just need to split to cut the extra volume. So I can split this volume using surface number 3. So this is the result that's we expect. So last step, I need to convert this volume become a surface. If I want to do the seal to the body, so I just need to join all these 3 surfaces. Or you also can extract, but this one I just simply join all these 3, only the 3 external surfaces. Then you can hide your split volume. So this is the last one. Get our rib. So after finish our rib file or rib features, so we need to test first, or we need to create the power copy. And then later if you really want to create a solid body, we can modify again. We test first, is it robust enough to adapt to a different position. So you go to power copy, create a power copy. So for our rib, the last operation that we do is a join 1. So you need to make sure you select the last thing that you create, join 1. For this example, join number 1. So this is a selected component, and then we need to make sure our input of the component here, when we select one by one, later we can see only these 3 surface, point and plane appear at this input. So basically this parent and child relationship. So basically join 1 is refer to, we create join 1 using split phase 1, split phase 2 and split phase 3. So this one is not an input, it's our we call the features under the read. So this one we need to read, we need to exclude. So you select all this, so you can see they already transfer here. Then check split one is belong to take surface. So this a child is a parent, so it's not our input. So this one also we need to transfer to selected component. So surface 3 is our input to split the grid. So this one no need to transfer, just keep here. Then this one extrapolate and then just so on, and just click to speed up. Line number 1 also not our input. So point number 2, point number 3. So this is point 1 is our input. So you keep here and then plane number 1. So after you properly select everything, so you can see input component is our main reference. And then using this 3 input, we can create all these features or profile to create our read. So then everything's okay, you select correctly. So in case you accidentally click this plane, actually you can transfer back as our input. So on you can transfer back selected component to input or vice versa. Then looks okay, and then you can click OK. Then you can go back to spec 3. Here you can see the power copy that we just created. So to apply this power copy, you go right click and instantiate. Here you can check these 3 input are required. So I cancel first, and then I need to create all the input. So first surface, just use the same one, surface number 3, so no need to create new one. And then point, you can create new point here using curve. So just simply put here, no problem. And then last input, you need to have a plane normal to curve exactly at this point. So all the input already here, you just can apply using instantiate. So surface 3, select input number 1, plane input number 2, and point is the last input. View. So if no error or anything, that means your successfully create the power copy. But you need to try to apply few location. For example, at the opposite. Then you can click OK. So that's how we create a power copy. And then we can save this power copy as our standard. So no need to redo again this power copy. So we can save under catalog. Save in catalog. So for example, you can save this one. Sorry, so you need to save your file first. Control save before you save in catalog. So new catalog, for example, save at desktop, easy to find. Plastic read. Okay, then you can save. Create new catalog. Okay. Then you can try to open a new file, new part, and then draw surface. So for example, I just use this command to draw my new surface. So we can try to test in a different file. So this one I need to trim first. So same thing, we need to create the input point, and also one plane. So I can try to apply my catalog. So save in catalog browser. So you can open your catalog browser, go to the desktop. I can search back my catalog. Open. Here is a copy that I created previously. So you need to have 3 input. Copy. Same thing. So surface 3, this one. So this one just a direction. Sometimes we need to select again. This one. So maybe there are some error. We try first. No, cannot. We need to define here. Boundary is not close. Maybe I select. So it's not robust enough to adapt to here. So we need to double check again. So, but basically that's the step by step. So I can create one more surface here. Try.